Okay, in this video we're going to be looking at this larger breadboard that we're going to be using for lots of lab assignments. And I feel it's really important that we get it set up properly in the beginning. There are a few gotchas that if we're not careful about can cause all sorts of problems, and I want to make sure that you can get your circuits built and tested easily. So one of the first things that you'll notice here is that on these strips, on this board in particular, there's a gap between the red and the blue lines here. And what I do is I take a piece of green wire, you can choose whatever color you want, and I cut it and then strip the ends and bend it. So what I'm left with is this little kind of jumper. And then I'm going to place that jumper, in this case, on the red to connect that whole strip. Now the reason that's important is because we're going to connect all these red strips together, and we want to make sure that we don't have a break, because otherwise if we use one of those connections, it might not actually have power, and that would be a problem. So I'm going to go ahead and put all those in. Okay, so I finished all those up. That didn't take too long. Next thing I'm going to do is connect all of the red and blue buses together. And how I'm going to do that is basically jumper them over to this strip. You'll notice I even put the little green jumpers over here on this side too. So I'm going to run red wires from all of these points, and that way everything on the board is going to have the same power source, and it'll be easy to make a lot of power connections. So one thing I didn't mention, I think I misspoke a little bit. I was saying connect all the red ones. You want to connect all the red and the blue strips with these jumper wires. And you want to connect all of the red and the black together. Now I've just got this one strip set up, but all of these now are connected together. Okay, so that's all done now. And the purpose of this, in case you're wondering, is we want to make sure that we have our 5-volt and ground supplies available in all of these strips. We're going to be building some circuits that have lots of different chips on them. And when we plug in our little power board like this, it will now power all of the strips on the entire board. One thing you can do, and maybe I'll do this a little bit later, is we can plug in the adapter, power it on, and make sure that we've got 5 volts on all of these strips, just to be on the safe side. This little breadboard power supply we're using is actually pretty cool. You want to make sure, let me flip it over here, you want to make sure that you have these jumpers set to 5 volts and 5 volts. If it's set in the middle, it won't power anything. Now if you happen to burn up one of the regulators, you could flip it over to the 3.3 volts and it'll still work. I'm going to probably give you 2 of these, so you should have a couple in case one burns up. But it usually will use an adapter for powering it, 9-volt adapter. There's a power switch with an LED to see when it's on. And we'll take a look at when we power up this circuit how that works in a little more detail. So in this class, the majority of what we're going to be doing is building logic gate circuits. And you should be a little familiar with these symbols by now. The AND gate on the top, the OR gate on the right, the inverter and the NOT gate on the bottom left. And we use these integrated circuit packages that we've been talking about, these DIP packages that look something like this. In this case, pin 1 is in the bottom left corner. The little notch indicates that end of it. But one of the problems I've had with students in the past, they make mistakes with either using the wrong gates or hooking them up improperly or flipping them upside down. So what we're doing is labeling all of these to make it a little bit easier for you to build the circuits. My goal is that you can not get lost trying to build the circuit, but actually see what's going on when we actually test the circuit. So for this logic circuit, one of the things we always want to do is identify what the different parts are. So I can write, for example, here, this is a 7404. This is 7408 on the top. And on the far right, we have a 7432. We also want to write the pin numbers. And based on the data sheet or more common, you can find the pin outs on the internet. Pins 1 and 2, 1, 2, and 3, and 1, 2, and 3. We're just using a few of the packages of all the gates. Then for the power pins, all of the power pins are going to be 14, are going to be tied to plus 5 volts, and 7 is going to be the ground pin for all of these gates. So I usually want to write these numbers out so I can kind of keep track of them as I'm doing them. Sometimes the logic gate circuits do not have all of this information, so you need to fill it in specific to the devices that we're going to be using. So let's go ahead and start building the circuit. Because the 7404 is on the left, I'm going to plug that chip in over here. Sometimes, most of these leads have been bent straight for you already, but if not, sometimes you have to straighten them out on a flat surface to make sure they all plug in properly. This one is a little bit bent. And you also want to make sure that all the leads are going in. So in this case, a couple of the leads are bent out. I'm going to straighten them a little bit and then plug it in. There we go. And you want to make sure that the leads are plugged into the rows directly on the bottom and the top of this insulating barrier between the two parts. So that's a 7404. You'll leave a little bit of space for the 7408, which is the AND gate, and then the 7432. Now, because we're only using a few of the gates from each of these packages, we're going to have a lot of pins that are left disconnected, and that's okay for this first circuit. The first thing I typically do is I connect all of the power leads first. And the reason why is that for whatever reason, those are the easiest ones to forget when you're actually wiring up the circuit. So I take care of that first. So we're going to use red for the positive. That's the common conventional color for positive pins. And that's almost always on these devices, pin 14 or 16, the top left corner. So I'm going to wire those three in like that. And the ground leads I'm going to connect on the bottom. And if you notice that I'm going on the little blue strip here and the red strip to keep track of which is which. So once the power and the ground pins are all connected, the next thing to do is actually start wiring the connections between the devices. Now, usually what I'll do is I'll use a highlighter to keep track of what I've connected here. So we've already covered the 5 volts positive and the ground for all these, so I'm going to wipe that out. And you'll notice there are only a couple connections here we have between the gates. So I'm going to pick a different color here. So between the AND gate, pin 3 here, 7408, going to be pin 3. That's going to go to pin 1 of the 7432, like that. Sorry, my hand covers that up when I'm doing it. And for the other connection, I'm going between pin 2 of the inverter, 7404 here, up to pin 2 on the 7432. So that's going to go all the way up here. And it could be in any one of these columns as long as it's the one that's connected to the pin. So once that's done, I'm going to mark each of these as I go to make sure that I don't miss any of them. Now the next part is we don't have anything else to wire up, but we're going to wire up switches, and that's the next step for this circuit. So the way that we test these inputs are by using these switches, little push-button momentary switches, and pull-down resistors to establish a base voltage, or actually a base current, if the switch is open. You can see here, if that switch isn't closed, that input is floating. And for this particular family of devices, we'll talk about device families in a few weeks, that input can take a very small current to turn it on, so we have to keep it at a ground level. And then when we press the switch, when we push the switch, it'll connect it to the 5 volts. So we use these little push buttons to do this. I'm going to place these on the board and then show you how I actually connect all the resistors together in kind of a cool way. So I'm leaving lots of space here. I'm going to put, and you want to make sure that when you push these switches in, that the pins are going on the sides here. If you place the switch like this, what happens is that all those pins are shorted and you'll short your switch out. So always make sure that it's placed like this. So I'm going to put one there. One here, if I can get it in, and slightly different switch, and this third one. That's going to be our ABC inputs. If you'll remember on the circuit, the A and the B pins are going to our AND gate, and the C is going to the input of the inverter. So I'm going to go ahead and wire those in. I've got A is going to pin 1. Actually, I'm going to move these switches down into the middle. That'll make it a little bit easier to connect these. I'm going to move them down into that middle row, like that. And so the input pin for A is that one. It's going to go to pin 1 on the 7408, right there. Move it down a little bit so you can see it. And the second switch, B, is going to go to pin 2 on the 7408, like that. That's the second pin on the 7408. And the third pin, C, is going to go to pin 1 over here on the 7404. So we wired those inputs, but the switches don't have any connection to the positive supply. So the next thing we're going to do is connect all of these together, like this, to the positive supply. And now hopefully you're starting to see the advantage of connecting all of these strips together on the entire breadboard. It's going to make it a lot easier to wire the circuit. Now one of the problems is it's a little hard to get to the switches, so you might need to kind of do a little bit of rearranging to make that work. But the third switch I'm going to put like that. So I can still get to these okay to test them. Not ideal. Sometimes the other way you could do it that might be a little bit easier is moving this connection up here and then plugging into the red strip on the top like that. That way your switch is not, no wires are in the way. So I'm going to go ahead and do that, and I'll show you the next step in a moment. So the next step is to add these pull-down resistors, and you have to be careful which side of the switch you're going to. We want to make sure we're going to the side of the switch where we're going to the gate input. So I'm going to take these resistors, and for example, the left side here is the side that we're connecting to. Slide this up a little bit. And we want those as pull-down resistors, so I'm going to run a resistor from there to ground. Next one to ground. And finally the last one to ground here. Okay, and we're almost done. Last thing we want to do is be able to test the output. And we're going to use a simple LED to do that. Now maybe you caught this mistake. I didn't at first. But you'll notice that I went to the wrong pin here. On our circuit, we're supposed to be connecting between pin 2 and 4, between the inverter and the OR gate. What I did is actually accidentally went to pin 3. It's a little hard to see this with the camera, my apologies. So I'm going to move that over. And then our output is going to be on pin 3 of our 7432. So I'm going to run that third wire over here, give it lots of space, that's that pin. And then we're going to connect an LED. Longer lead is positive on this LED that we're using here. And I'm going to connect it between those 2 points, like that, and then connect the resistor to the ground. Now, I'm going to have to change this in my circuit because in reality, since I was locked out of the lab over the weekend, I had to substitute a different part, which is actually 7402, which is a NOR gate. And so I'm going to kind of cheat a little bit to make the circuit work like we'd expect it to by flipping the actual output of the LED. But for now, let's just pretend it's a 7432 and everything's wired correctly. And we'll hook up the power supply and we'll test this and see if it works. Now, before we actually power up the circuit, we want to check and make sure there aren't any short circuits. So I have this meter set for 2,000 ohms on the 2,000 ohm rating, and if I had a short circuit, it would show something on the very low value of resistance in ohms. So I plugged in a wire here for the positive and the negative, and I don't see anything that shows a short circuit that would look like that. I just want to do that to make sure I don't accidentally damage the power supply if any of these little jumper wires that we made, for example, across these points, if they accidentally touched or shorted. So you want to double check that before powering the circuit. Okay, so if we take a look at our original schematic here, we would expect that the output would turn on if both A and B were on, or if input C was low because it's inverted. So let's power this up and check it and see if it works. Okay, so the LED comes on right away, and that's because the C input is inverted. So if we press that button, it turns off. Okay, and then if that input is low and we press both of the inputs for the AND gate, it turns on. So that indicates, looks like everything is working for the circuit. It looks a little messy. There are ways you could use shorter jumper wires, but the longer ones that we use are a lot more convenient. So next we'll talk about the power supply.